In the previous episode, we showed you how to complete the basic setup of the rotary probe system. In this video, we'll walk you through how to properly and easily connect the control unit to the motion controller. For this wiring demonstration, we'll use the rotary probe body, a manual control button, a power interface, and a device simulating a typical CNC motion control board. This demo box includes 4 inputs and 4 outputs, which can be configured for either NPN or PNP operation. Last but not least, we need the control unit, the brain of the entire system. First, we'll connect the manual button and the rotary probe body using their dedicated connectors. Next, we connect the control unit to a DC power supply. The voltage should be between 12 and 24 volts. When the power is turned on, the rotary probe automatically returns to its home position. In the next steps, we'll focus on connecting to a motion control board that uses NPN inputs and outputs. An NPN output means that the common line for the outputs is connected to ground, while the common line for the inputs is connected to the positive pole of the power supply. The control unit has 2 inputs from the control board, one for setting the probe position and the other for disabling the probe guard function. These inputs share a common line, which is connected to the positive pole in an NPN configuration. The remaining 2 terminals are connected to the control board. Activating the up-down input causes the probe to rotate into its lower, working position, while deactivating the input returns it to the home position. In the configuration tool, this input can also be set to toggle mode, functioning the same way as the manual control button. The control unit provides 3 outputs: a combined signal output from the probes, an error output, and a position reached output. Each output occupies 1 terminal pair. In an NPN configuration, all terminals labeled E are connected to the negative pole of the power supply. The terminals labeled C can now be connected to the inputs of the motion control board. Now we can test the output functionality. When the probe reaches its working position, this is indicated by the position OK LED as well as by activation of the corresponding output. A probe trigger is reflected in the input state. The signal passes through the control unit and together with output indication is transmitted to the motion control board. If the probe is triggered while the block signal is inactive, the stop output is also activated. This is the core function of the probe guard. When the block signal is active, probe triggers are passed through without activating the stop output. The probe guard function will be explained in more detail in one of the upcoming videos. The manual control button and the input from the motion control board can be used simultaneously. The button always operates in toggle mode and the control unit responds to the most recent change, whether from the button or the input. When the probe is in the working position, the position OK output remains active continuously. When the probe is in the home position, the signal is only active for a short moment and then stays inactive. This allows the motion control system to recognize whether the probe is ready for measurement. The control unit includes a switch for setting the output polarity of the probe signal. It can be set to either normal or inverted. Normal corresponds to a normally open switch, meaning the output is active only when the probe is triggered. In inverted mode, the output is active while the probe is idle and deactivates when the probe is triggered. This setting applies to all connected probes and sensors. By adjusting the output signal polarity and configuring the input and output wiring, you can achieve any combination of NPN or PNP as well as normally open or normally closed behavior. As mentioned in the previous video, the control unit can also be connected to any 2 additional sensors or probes. Connect a fixed tool length sensor to the terminals labeled FTLS. The sensor signal is combined with the other probe signals and transmitted to the motion control board. By installing the cable with a magnetic connector, you can connect devices such as a spindle-mounted probe or a manual tool length sensor. The signal from this sensor is also transmitted to the motion control board. You can conveniently configure the entire device set in our web store. The NPN setup is now complete. Let's quickly switch the wiring and go over the key details of the PNP configuration. In a PNP setup, an input is activated by applying positive voltage from the power supply, and an active output provides a positive voltage on its terminal. In a PNP configuration, the common line for the motion control inputs is connected to ground, while the common line for the outputs is connected to the positive voltage. On the control unit side, the common input line must be connected to ground, and the output terminals labeled C must be connected together to the positive pole of the power supply. The output terminals labeled E are then connected to the PNP inputs of the motion control board. And finally, the input terminals of the control unit are connected to the outputs of the motion control board. Now our updated PNP setup is complete and we can once again test all the functions. This includes signal transmission from probes and sensors, the probe guard function and the block input, as well as the up-down input control. To finish, we'll tidy up the wiring and we're ready for the next part of the tutorial. In the upcoming section we'll cover how to connect the control unit via the RS485 bus. This interface allows you to configure additional parameters and control the probe using the Modbus protocol.